Welcome, physics friends, to 1.5, which I have entitled Data, Relationships, and Graphing. Today we're going to be talking about data. We're going to talk about measurements, precision, accuracy. We're going to be talking about different types of relationships. When you start to graph data, is it trending somehow? Is it linear? Is it quadratic? Is it inverse? And then we're going to talk about actually graphing data. I've got a data set right here that we're going to physically go into Microsoft Excel, which is the program that I use and that pretty much everybody uses who does anything with data, unless they have a specialized program that does it. But this is like a good universal program to actually graph some data. We're going to get numbers, we're going to graph them, we'll go from there. So let's get started. The first part is measurement. What is a measurement? Whenever we measure something, what it is, it's a comparison. A comparison between an unknown value and a known quantity. A known standard quantity. Precision. When you take measurements, precision refers to how close the measurements agree. Accuracy is how close the measurements are to the actual value. Now, sometimes in our labs and in our measurements, there's a precision issue. You can be precise and not accurate, as this one is. This could be caused by maybe you're taking the data wrong, but you're doing a good job taking it wrong every single time. Like maybe you don't use that. You know how some rulers, the plastic rulers, the zero isn't exactly on the end? Maybe you're doing that. Maybe you're putting something on a scale and you forgot to tear the value. You didn't tear it. So there's some consistent issue that is just giving you the wrong data, but your data's good. So that this is usually a systematic error, something that you're doing time and time again consistently that is just not right. Unlike this one here, this is both accurate and precise. This one is accurate, but not precise. Now, some common causes here, just not taking enough data samples. People will do a lab and like, oh, look it totally agrees. Does it, or did you get lucky? Does it, or did you get lucky? You have to take multiple data points to ensure that what you're getting is the same answer. Now, when you get into real science, there's real numbers for these statistics. There's certain standard deviations that it has to assume in order to be considered valid. Now, this is the worst part. It's not accurate and it's not precise. Sloppy measurements that are not close to the actual values. Now, relationships. Well, I'm sorry, before we get to the relationships, when we graph the dependent variable always goes on the y-axis. It's the variable that fluctuates. A lot of time it's the variable that you measure. It depends on whatever the x variable is. So this is something that's fluctuating as time marches on. It's going up, it's going down. That's the thing you're actually measuring. The independent variable is what you're keeping constant, like the control. Oftentimes it's the variable that goes up incrementally. It's the variable that the experimenter controls. Like in this experiment right here, length of a spring. So what they're doing, it looks like they're hanging 5 grams, 10 grams, 15 grams, 20 grams, 25 grams. They're hanging predetermined amounts of weight on a spring to see how far it stretches. And then how far it stretches, the length, that is the dependent variable. The length of the spring depends on how much mass is hanging from it. Now, there are 3 different types of relationships we're going to be dealing with in this semester, or this unit, this year. The first is a linear relationship. A linear relationship is just like what it sounds like. In algebra class, if you go up a certain amount, it then increases that same amount. So going up, so it looks like here every 5 it goes up, it looks like it goes up 5 centimeters. Another one, and they ascribe to the equation y equals mx plus b, and you know that m is the slope and b is the y-intercept. Now, in a quadratic equation, as you go up, it increases. So if I went from 0.4 to 0.8, I'm going from 1 to, it looks like 4. But then when I go from 8 to 1.2, I'm going up more. And every single time I'm going more and more. This is called the quadratic relationship. It's the shape of this is a parabola. And it ascribes to the equation y equals ax squared plus bx plus c. You've all seen that before because in algebra class, you had to pass algebra to get to physics here with me, that this is the general formula for the equation. And the last one is an inverse equation. We call this shape right here a hyperbola. The shape right here is a parabola. And this shape right here is a line. Now, in a hyperbola, we call this line, it's getting closer and closer to this line, but we'll never actually touch it. We call this line an asymptote. And equations of this have the general formula y equals a over x. For example, this might be something, 25, it equals 5. So y equals a over x. So the y equals 5, and as the x value is 25. So that means that a equals 125. So this equation is y equals 125 over x. This one here, not so easy to find. My linear equation is a little bit easier to find, and that would be something like y equals, I could find the slope, the rise over the run. Looks like it goes up 5. My y-intercept looks like 13.7. This one, a little bit trickier to find, and I'm going to show you how to actually figure out those lines, because these equations are really important for us to forecast. We can predict the future. For instance, how long would the spring stretch if I put 50 grams on it? Right here, the distance of a ball versus time. What if the ball fell 4 seconds? How far would it go? Current versus resistance. How much current would there be if I had a resistance of 100 ohms? So I'm going to show you, and we're going to use the program Microsoft Excel. So I'm going to key up Microsoft Excel here. These are my data. I've got 3 sets of data, and I want to graph each of these 3 sets of data. So I'm going to open up Microsoft Excel, and I've already got the data plugged in here. So the first thing I want to do is I want to make sure that they all have the right number of sig figs, and you can see right here this 16 does not. So let me zoom this in a little bit so it might be easier for you guys to follow. There. So I'm going to highlight this, and I'm going to click this button right here. I can give it more zeros, or I can give it less zeros. Now, if you want to do all of them, I can highlight an entire column. Let's see. Nope, maybe I just got to highlight all of them here. There. I can give it more zeros. I can give them less zeros. Got one more. give it another 0. There. So now I've got all the right numbers of zeros here. The next thing I want to do, I'm going to graph this. So in order to do that, Excel is really good at graphing data. I'm going to grab both sets. In order for this to work, you have to make sure your independent variable, the x variable, is on the left. Make sure the x variable is on the left-hand side of your column, and then you can do this. So I'm going to highlight both of these sets of data, and I'm going to hit Insert, and then I'm going to insert a scatter plot. And I don't want it to connect the lines, so I clicked that one right there. Let me try that one more time. I'm going to highlight all these values right here. I'm going to go up and hit Insert, Scatter Plot. There it is. And I can see from this graph right now that this is a linear graph. So what I'm going to do is I'm going to title this thing appropriate. If I click on this, I can highlight it and I'll just give it an appropriate name. And I think that this was spring length versus mass. So I'll just type in spring length versus mass. And you can't see that it's showing up. I'm just going to hit enter and hope that it took. Yeah, and there it goes. Spring length versus mass. Now the next thing I have to do, whenever you make any chart, you have to label your axes. And your axes labels have to have units. So I'm going to click on my chart here. I click on it. Then I go up to Chart Tools, Design, Add a Chart Element, an axis title. The horizontal axis, in this case, is going to be mass. So I'm going to highlight this, mass, and then kilograms. Hit enter. And then I'm going to give my Y values. It was spring length in centimeters. So I'll insert chart element, chart axes titles, primary vertical axes. And we're going to label this spring length in meters. I think, oh, centimeters. This is not cooperating, that's for sure. Well, that's okay. So here's my first one. I can resize it to whatever I want. Now the next thing I'm going to have to do is draw the equation on there. And in order to do that, what I'm going to do, I'm going to click on this guy, and I think I want to do, let's see what I can click here. I want to click Add Chart Element, and I'm going to add a trend line. Now this is linear, so I'm going to go down here to more trend line options, because in order to do this, I have to select, let's see here, it's going to be this third one over here, linear, display the equation on the chart. I want to have that, it's behind my face right now, you can't see, but there's a, after I click this one at the very bottom, it says display equation on the chart. Linear, and then enter. Does that work? There it is. So here's my actual equation. Y equals 0.0771x plus 13.725. So let's do our next one. So we'll highlight our values, insert a trend line. There it is. Scatter plot. We'll title it appropriately. Current versus resistance. I'm going to give it my axes titles, horizontal. That was current in milliamps. And then I'm going to give it a vertical. It's going to be resistance in ohms. I don't have to get that symbol. Don't worry about that symbol just yet. So I'm just going to type out ohms. And now I have to put the equation on there. So I'm going to go add chart element, trend line. This one, you have to select up here. This one's going to be a power. Let's see. Display the equation on the chart. Yeah, power. Enter. See what it gives me. Yep, this looks close. Y equals 75x to the negative 1 power. So there's my next graph. And I'll do my third graph here. Highlight it. Insert. Chart. This one looks quadratic. I'm going to skip over putting the titles in because I think that you can follow that. But I'm going to insert my trend line, because this trend line, if you look, this trend line is going to be exponential. No, it's going to be a polynomial of order 2. When you're selecting a quadratic, it's a polynomial of order 2. Display the equation on a chart. And there it is. A polynomial, and you can see it fits the form. Now, if I was going to print this out, I'll show you another clever trick that someone showed me one time. When you're going to print all of these out. When you print these, File, and you hit Print. My room is room 29 when you're doing your printer. The library is LMC, the copier, or the color. You aren't going to be printing in color. But room 29 or the LMC copier are the two printers that we have available. If you select, see this custom margins down here? No, that's not it. Scaling. Fit sheet on one page. Can you see right now that it looks like I'm getting cut off down here? My graph, so if I fit everything on one page, now everything fits on one page nicely, and then when you hit print, everything will print beautifully. So that's how you graph your data. You'll be doing this in class using Microsoft Excel to graph these exact things that I just did. So you'll be going through the same processes that I did. So good luck to you, and thank you for watching.